I'm going to introduce our work, a dual-weighting label assignment schema for object detection. Label assignment is a heated topic in object detection in recent years. It can be regarded as a process of assigning a positive weight and a negative weight to each anchor. LA can be roughly divided into two categories, hard LA and soft LA. The core idea of hard LA is to find a proper division boundary to split the anchors into a positive set and a negative set. Typical measures are FastRCN, SSD, FCOS, and ATSS. In soft LA, positive and negative weights is a continuous value ranging from 0 to 1. Our work focused on soft LA. Existing soft LA measures have three steps. First, a consistency degree T between the classification height and the regression height is defined. Second, the inconsistency degree is then defined as 1 minus T. Finally, W positive is defined as scaling factor multiplies T, and W negative is scaling factor multiplies 1 minus T. They have two characteristics. First, they mainly focus on the design of T and the scaling factor. Second, positive and negative weights are highly correlated, which can impair the training efficiency. In this paper, we propose a new soft LA schema termed as dual weighting to specify W positive and W negative from different perspectives and make them complementary to each other. An advantage of DW is that it can well distinguish the importance of anchors by assigning them distinct positive and negative weight pairs. This figure shows the whole framework of DW. The left part shows the overall detection model, which consists of backbone, FPN, and detection height. The right part shows the weighting process. Next, we will describe the weighting functions of DW in detail. According to the evaluation metric in object detection, a prediction in inference will be defined as a correct one if and only if. First, the LU between the predicted bounding box and its nearest GT object is larger than a threshold theta. Second, no box that satisfies above condition ranks in front of the current box. In a word, a high classification score and a high LU are both sufficient and necessary conditions for positive prediction. Considering this, we define the consistency degree between the classification and regression height T as the multiplication of the classification score and the LU. To encourage a large variance of positive weights among different anchors, we add an exponential scaling factor to formulate the final positive weight. The negative weight is defined as the multiplication of two terms. The first term is the probability of being a negative sample. According to the evaluation metric of COCO, a predicted bounding box that doesn't satisfy the LU metric will be regarded as a negative detection, even if it has a high classification score. That is, LU is the only factor to determine the probability of being a negative sample, and it should satisfy the following rules. When LU is smaller than 0.5, P negative is 1. When LU is from 0.5 to 0.95, P negative should range from 0 to 1. When LU is larger than 0.95, P negative is 0. For simplicity, we instantiate P negative as a linear function. The second term is the importance conditioned on being a negative sample. During inference, the evaluation metric requires that negative predictions should rank as behind as possible. This means that during training, negative predictions with larger classification scores are more important, as they are hard training samples. Considering this, the importance of negative samples is defined to have a positive correlation with the classification score. This slide shows the final loss functions. We compare our DW with existing LA measures on COCO. The experiments shown in this table are all based on ResNet 50 detector under the 1 times schedule. We can see that our measured rate is 41.5 AP, which to our best knowledge is the first method to achieve a performance of more than 41 AP on COCO without increasing any parameters and training cost over FCOS ResNet 50. Please come to our poster for more information. The code has been released. Thank you.